Hello, Farah, please you introduce, madam.
Yes, sir. Good evening, everyone. Uh, Dr. Sumana Datta completed her post-graduation with a specialization in clinical psychology from the University of Calcutta. She was awarded the Junior Research Fellowship from the Indian Statistical Institute in 2013 and conducted her PhD research there as a research fellow of the Psychology Research Unit from 2013 to 2019. Her contribution to academia have been recognized with the Best Researcher Award in 2020 and the Best Teacher Award in 2021 from Adamas University, Kolkata. She also received the Arise Research Grant from Adamas University for her work in psychometry. Dr. Sumana Datta is currently an assistant professor in the Department of Psychology at Government General Degree College in Singapore. Previously, she held positions as an assistant professor in the Department of Psychology at St. Xavier University, Kolkata, and as the assistant professor and head of the Department of Behavioral Science at Adamas University, where she also served as the assistant dean of student affairs from 2019 to 2022. She is honorary research secretary of the Bangladesh Psychometric Society, honorary member of the Research Advisory Board of the Institute of Psychometry. She has
Okay.
taken class on interview technique and grounded theory in 1 month online certificate training course of qualitative research methodology in June 2023 organized by RPRIT. In addition to her other accomplishment, Dr. Sumana Datta's paper co-authored with Dr. Datta Roy and Murshida Khatun was published in the Journal of the Indian Academy of Applied Psychology in July 2023. The paper titled Verbal Reasoning Abilities Predict Academic Achievement of School-Going Adolescents, Evidence from the Indian Population highlight her valuable contribution to the field of psychology. Okay, sir. Okay, ma'am. Over to you.
Thank you, Farah. Now, Shumana, please start your.
Okay, thank you so
Yeah.
much, Farah. Um, okay, so I would like to share my screen with all of you. Yeah, I hope it's visible.
Yeah, visible.
Okay, so all right. So as sir mentioned, I'll today in this presentation I'll discuss very briefly about each of these things. As you can see, there's a long list of things which sir has asked me to discuss in this class. So each of these actually is a very elaborate and detailed part. Specifically, when we will be talking about the statistical techniques involved in meta-analysis, then you will probably you may find a little difficult to uh, you know uh, cope up with the pace. But since the time is short, I will try to focus on the conceptual aspects of these topics rather than the mathematical aspects. So I'll start with the meta-analysis, but before talking about the meta-analysis as a process, we first need to understand about scientific evidence. Okay, so meta-analysis actually is something, it's like a solution to a problem, the problem being the issue of scientific evidence and its importance in any particular discipline that you can consider. So the first question that comes is, what is scientific evidence and why is it important? So scientific evidence, in any discipline that you consider, you will find that scientific evidence is something that is made up of data and observation, which is either carefully collected in a lab or in the field. Okay, and why do we need this scientific evidence? Because it forms the basis for objective and unbiased explanations of the natural world. Okay, so what kind of data do scientists collect? Scientific evidence can be both qualitative or quantitative in nature, right? So we know that qualitative data, it includes making observations, then writing some, sometimes it can be textual data as well, observing some video, some audio file. All these can be qualitative data. And quantitative source of data means the numerical information that we can obtain by counting or measuring and doing calculations. So there are several evidences of scientific evidence that that are available in different fields. Okay. So if we try to uh, hierarchically sequence the different types of researches which provides us with the strength of scientific evidence, then you will find that um, at the very bottom of this hierarchy, probably this will give you a better idea. Case reports, opinion papers, letters which are published in the different journals, they are the weakest form of scientific evidence. Okay. So we know about this case reports, okay, where one particular case study is being reported, okay, or a particular researcher is explaining some opinion or writing a letter to the editor. All these are very subjective in nature, and of course, the scientific, the strength of the evidence provided is the least. Okay. Then as you go up, you have animal trials, in vitro studies, then cross-sectional studies, then case control studies. All these are different types of researches that we carry out. So I'm not going into the details of all these because these are not the focus of our study today. Just to make you understand that as we go up, you will find that the best form, among all these can be the randomized control trials, which is very very experimental in nature. You will see here case reports, case series, case control studies, cohort studies. All these are observational in nature, while randomized control trials, these are experimental in nature, experimental research. Okay. So RCTs are also considered to be very strong scientific, providing very strong scientific evidence. But if you go up, further up, you will find that meta-analysis and systematic reviews actually provide the strongest form of scientific evidence. Okay. So obviously, we have to understand that when we are talking about these meta-analysis and scientific reviews, why or how does it provide the strongest type of scientific evidence? Here we are not conducting an experiment, right? In meta-analysis or in systematic reviews, we do not conduct any experiment. We do not conduct any hands-on research, or we do not collect data, primary data from individuals. This action part is actually missing. What we do, we actually collate data from different studies which have already been conducted around the globe. Okay. And the very very strong and complicated statistical analysis that we follow for conducting a meta-analysis actually gives the basis of this very strong proof of scientific evidence. Okay. So meta-analysis is actually a statistical combination of results from two or more separate studies. Okay. So this actually takes advantage of all the other studies which have already been conducted. Okay. So it statistically combines the results from all these different studies together. Potential advantages include an improvement in precision. Okay. And when we are talking about this precision, it is not just a literal word that we are referring to. It's a statistical precision that we are talking about. Okay. I will explain how, what kind of statistical precision we are talking about. Okay. Number two, the ability to answer questions not posed by individual studies. So, for example, every day, thousands of different studies are being conducted in different cultures with different populations around the world on a specific topic, right? For example, during COVID, if a researcher wanted to, understand what kind of, mental health issues the LGBTQ group or LGBTQ population actually faced during the COVID-19 pandemic. Okay, so this question cannot be answered by one single study. Okay, one single individual study cannot answer this question. So a researcher can actually take into account a number of studies and can answer this question if the researcher can conduct a systematic review or a meta-analysis in this case, right? The third advantage, the opportunity to settle controversies arising from conflicting claims. Okay, so sometimes it happens. You will find that in different disciplines it happens that there are conflicting claims. Okay, in psychology, I don't know how many of you are from psychology background, but in psychological research, you will see that there are so many different cases where you will see that some of the studies they are suggesting, it is very common with gender differences. If you are trying to look into gender differences with respect to a particular trait or an event or a phenomena, you will find that there is always a number of studies which are supporting that there is a very strong gender difference with respect to this, and then there are another bunch of studies which will be suggesting that no, there is no gender difference. Okay, so this types of conflicting claims are always there. So a systematic review and meta-analysis can actually provide a very suitable solution to this conflicting claims. Okay, so it is important to be familiar with the type of data that result from measurement of an outcome in an individual study and to choose suitable effect measures for comparing intervention groups. Okay, this conclusion is statistically stronger than the analysis of any single study due to increased number of subjects. When you are collating different studies, say for example, you are collating the data from 10 different studies, right? So one single individual study would have considered only 500 participants, but when you are collating data from 10 different studies, you get a very strong sample size which can be anywhere between 5,000 or to 10,000 to 20,000 or even 1 lakh or more than that. Okay, so of course any statistical conclusion that you will be drawing will be very strong than that from any single study that you will be considering. Okay, so that is one reason. Then of course it is again very strong because of the greater diversity among subjects. So you have subjects from different backgrounds you are considering, so of course you have lots of variations in the data. Okay, or accumulated effects and results. So generally we consider accumulated effects from all the subjects, all the studies taken together, and then we conclude about that particular phenomena. So that's why any conclusion that we draw becomes a very statistically very strong conclusion in comparison to any single study that you will be doing. So meta-analysis refers to the statistical analysis of the data from independent primary studies focused on the same question, which aims to generate a quantitative estimate of the studied phenomenon, for example, the effectiveness of the intervention. Okay, so there is a very subtle difference between this systematic review and meta-analysis. You might have noticed that right from the beginning I have been mentioning these two together. That's because these two are very much overlapping, and it's kind of these two like they complement each other. It's something like that. Meta-analysis is just an extension of the data. Okay, so I'll explain how these two differ. A systematic review is defined as a review using a systematic method to summarize evidence on questions with a detailed and comprehensive plan of study. A systematic review is a process that involves selecting, evaluating, and synthesizing all available evidence. Okay. A meta-analysis, on the other hand, is a statistical approach that combines the data from a systematic review. All right. So what happens here is that systematic review gives you all the data which you need, okay, about the empirical researches which have been conducted to answer a specific question. Now, when you are combining all this data and statistically analyzing that data to get some conclusion, then it becomes your meta-analysis. Okay, so both are highly regarded as generally resulting in reliable findings. Both of these methods support conclusions based on expert reviews, case control studies, data analysis, etc., versus mere opinions and musings. So as I mentioned, that both these are provide us with very the strongest type of scientific evidence in comparison to opinions and letter writings, etc. And both these methods have different methodology and purpose, and these can be even combined. Okay, so all these are, you will find several studies where meta-analysis and systematic reviews have been done together. Okay, there are several studies where you will find both these taking place together. And also there are studies where you will find only systematic review done, or in some other studies, a meta-analysis of the on a particular topic has been done. So you can be doing a systematic review separately in isolation, or you can be doing a meta-analysis in isolation, or you can be doing both these combined together. Okay. All right. So how do we conduct a meta-analysis? All right. So I hope all of you are able to follow whatever I'm talking about. Is it okay?
Yes, ma'am.
Yes.
All right. Please feel free to stop me somewhere, if you find any difficulty to understand, or you can just write it in the chat box. Okay. So how can we conduct a meta-analysis? So it follows a number of steps. Okay. So it starts with the problem formulation, then searching the literature, then screening potentially eligible studies, then data extraction, coding, and critical appraisal, then data analysis and synthesis, then reporting and dissemination, and finally updating or reanalysis of data. Okay, so the first 3-4 steps are manageable. Okay, of course, very complicated. I will explain each of these, but you will find that it's kind of manageable. The next part becomes very complicated, where you have to apply the data analytic tools, because these are hardcore statistical techniques which you will have to follow. And since meta-analysis requires, it provides us with the strongest type of scientific evidence, the type of analytic tools which are used, these are very, very complicated actually. Okay. Reporting and dissemination is also, it's fine, it's manageable. And updating or reanalysis of data is a step which is basically an optional one. You don't have to do it every time you do a meta-analysis. Maybe sometimes we do it. Okay. So I'll start with the problem formulation. All of us, we are acquainted with research problem, right? What a research problem is. Okay. So research question of any systematic review or meta-analysis should be, like any other research problem. Feasible means it should be possible. It should be interesting. It should be novel. It should be ethical, and it should be relevant. Okay. I guess you all are able to understand this part. Feasible, of course, the possibility should be there. Okay. What makes it possible? You should have enough number of studies, okay, based on which you can conduct a systematic review or a meta-analysis. If you select a particular topic which on which maybe you are getting only 2 to 3 different studies have been conducted, then of course it is of no use. You cannot actually do a systematic review or meta-analysis on that particular topic. So it should be feasible. Interesting in the sense scientifically interesting, something that is providing the scientific community with some novel insight. It should not be a repetition of what we already know. Okay. Ethical in the sense that it should have ethical clearances, And I will discuss that before doing any systematic review or meta-analysis, there is a procedure that we follow for getting the kind of approval that we need for conducting that review or meta-analysis, and it should be relevant as well. For example, you must have seen that after the COVID, in the post-COVID period, several meta-analysis and systematic review has been conducted. If you go to Google Scholar or any other database, you will find that there are thousands of studies which have been done, and several meta-analysis and systematic reviews were also done on related to COVID-19 pandemic. But if you search for it now, then you will see that the frequency has gone down to a very large extent. Why? Because 2 years after the COVID-19 pandemic, the relevance of the pandemic is actually quite less these days. Okay, now we have we have recovered and we have moved on, right? So now it is not very much relevant. If you want to do a review on COVID-19 pandemic now, probably you will face certain difficulties in getting an approval. Okay, so a clear, logical, and well-defined research question should be formulated right at the beginning. Generally, two common tools are used, PICO or SPIDER. PICO stands for Population, Intervention, Comparison, and Outcome. It is mostly used in quantitative evidence synthesis. And SPIDER stands for Sample, Phenomenon of Interest, Design, Evaluation, Research Type. Okay, and this was actually proposed for a as a method for qualitative and mixed method search. Mixed method search means where you are combining qualitative and quantitative. So it has been found that PICO holds more sensitivity than the SPIDER approach. PICO is usually used for systematic review and meta-analysis of clinical trial study. For observational studies, okay, observational studies means case control studies or cohort studies, cross-sectional studies. In such type of studies, in many topical and epidemiological questions, generally it is enough to use the patient and the outcome only to formulate the research question. But we must clearly indicate the population, then the intervention or exposure, then we can do a comparison between the two and find out the outcome. Okay, so this is a sequence that needs to be followed for formulating a problem. Okay, so what it means is that when you go through each of the study, you should focus on each of these aspects to finally formulate the problem for your own systematic review or meta-analysis. Okay. As I was mentioning that when you are right at the beginning, when you are trying to formulate the this topic or a problem for your meta-analysis, you see, meta-analysis or systematic review, it requires lot of planning on the part of the researcher. Okay, what you need to do is prior to start with your review of literature, you need to first register your proposed problem in a website like Prospero. Okay, so this is basically what we call the protocol writing and registration. Okay, so this one, it is not like a mandatory step that you need to follow, but it will actually guarantee a lot of transparency in the research process and protects from duplication problems. So there are certain journals which makes it mandatory that if you are trying to submit a systematic review or a meta-analysis done to that particular journal, it will ask you that whether it is this problem which you have focused on, whether it has been registered in Prospero or not. Okay, because this Prospero is actually a part of the National Institute for Health and Care Research, and they maintain an archive, a database of all the different reviews which are being conducted around the world every day. Okay, so what they do is that once you do a registration of a particular research problem, you will have to provide them with a timeline. Okay, they will take some time, they will review the problem, and they will tell you whether you can go ahead with this review or not. What they do is that they check whether there is a duplication that is happening or not, whether this type of review has already been conducted somewhere or not. So if it's something which is very new, then probably you can go ahead without getting it registered at NIHR, and mostly you are good to go. Most of the journals, they accept it. Okay, but if it's something which is a very a topic which is very current, for example, someone wants to do a systematic review or meta-analysis on what is the prevalence of depression in the Indian population. Okay, or in the world population, or in generally in any one particular population, like the old age or something. Okay, so it's a very common topic, very current one, right? So in such a case, there is always a possibility that someone somewhere else probably has already registered that problem in Prospero, and will be completing and submitting his or her research before you have already done it. So if you do not register it here and you go ahead with your work, okay, then 3 months or 6 months down the line, when you are submitting it to a journal, they will be telling you that, okay, this has already been published. Why have you bothered to do a analysis of, systematic review or meta-analysis on this particular topic? So that's why if you are working with something which is a very new topic, okay, then you can go ahead without registering into Prospero. But if you are doing something which is a very current topic, and that thousands of researches are being conducted every day on this particular topic, then it's always a safe step to get your topic registered, okay, and get this approval from their end. Okay, so they also look into the different steps which you will be telling them, which you will be mentioning. Okay, and it's kind of a ethical approval as well that you will be getting from their end. Okay, next step, the title and abstract screening. Okay, so when you are looking into the articles for your systematic review and or meta-analysis, there are a number of things which you have to follow while looking into the existing literature on that particular topic. So decisions to select retrieved articles for further assessment are based on eligibility criteria to minimize the chance of including non-relevant articles. So we start with creating some eligibility criteria for a particular study. Okay, so this eligibility criteria should be very clearly defined, that okay, these are the eligibility criteria I'll be looking at. All right. According to Cochrane guidance, 2 reviewers are a must to do this step. But as for beginners and junior researchers, this might be tiresome. Okay, because what happens in this particular step is that you go through hundreds of studies, okay, and not just the abstract. Okay, you have to screen the title, you have to look into the details, whatever details you are getting, okay, and then try to get the full paper as well for your research. So it's very tiresome when one single person handling hundreds of studies together, and right at the beginning it starts with not just 100, it can start with 500 or 1000 or even more than that. Okay, so generally what happens is that 2-3 reviewers, they start working independently to reduce the chance of error. Okay, and in sometimes if there are large number of authors, then they can form teams, and then carry out the work to do the scrutiny and ensure proper conduct. Okay, so this step is also required to make sure that duplications are not there. Duplications means what happens is that when you are searching for a particular study, you will find that the same study has been indexed in Google Scholar, then in ResearchGate, then in PubMed. So it becomes difficult when you are going through hundreds of studies together. It becomes difficult to remember that, okay, I had already downloaded this particular paper from PubMed, and now I'm getting the same one in Google Scholar. It becomes very difficult to track that. Okay, so that's why you need a lot of people to work with you so that you can actually do a scrutiny of the things and exclude duplications. When there is any doubt about an article decision, the team should be inclusive rather than exclusive. Okay, means that generally we include that particular article, and rather than excluding it until the main leader or PI makes a decision after discussion and consensus. So if the PI or the leader finds, the first author or whoever is in charge of the research finds that probably including this particular study is not justified in any particular way, then only they exclude. Okay, all excluded records should be given exclusion reasons. So you start with, suppose you start with 500 studies, and then in the next step you excluded 200 of them. You have to give justifications. Why have you excluded this 200 studies? Okay. All right. So systematic reviews and meta-analysis actually, requires manual search. So one has to exhaust all possibilities to reduce bias by performing an explicit hand searching for retrieval of reports that may have been dropped from first search. Okay, so there are many ways through which we can, do this type of searching. Searching references from included studies and reviews. So you already have certain studies and reviews downloaded. You look into the references and then do the searching again. You can be contacting authors and experts. So there it happens that there are some people, some stalwart people who are working in the same area on a same particular topic for their entire lives. Okay, so they have like lots of publications on the same topic. Okay, published over a number of years. So you can be contacting those authors, those experts, to send you their research, and you can look into those research to consider whether you are going to include those in your review or not. Okay, and also looking at related articles or cited articles in PubMed and Google Scholar, and then there are many other different search engines as well. So these are, I think all of you are acquainted about Google Scholar and PubMed. Yeah, all of you are acquainted with it.
Yes,
Yes,
ma'am. Yes, ma'am.
Okay, good. So are you all acquainted with these search engines as well? Lens.org.
No, no.
No, ma'am. No, ma'am.
Yeah. Elicit, Perplexity, and Semantic Scholar. These
Semantic
are,
scholar, we know.
yeah, Semantic Scholar, good. So the rest of these are also, all these are AI generated search engines, which actually provide with a very, very huge database. They all these have huge databases, and you can have free registered accounts. As you can see, I have free registered accounts in all these different search engines, and you can search with a lot of precision, and specific things you can actually search if you go to each of these search engines. So you can also use these different search engines to get access to this different literature. Okay. All right. So once you have got the access to this different literature, well, conventionally it happens that you are able to download a lot of different full papers, articles, journal articles, and materials which you can consider for your systematic review or meta-analysis. Then comes the tricky part. Okay, so this Prisma is something that is very important for conducting any systematic review or meta-analysis. Prisma stands for Preferred Reporting Items for Systematic Reviews and Meta-Analysis. Okay. Well, okay. So what is this Prisma? Now, Prisma is actually, it's a model that you need to follow when you are trying to, screen the different literature for your meta-analysis and systematic review. So this Prisma model looks something like this. Okay, so here you can see uh, what is written here: identification of studies via databases and registers. Okay, so all these databases include the Google Scholar, PubMed, Semantic Scholar, Perplexity, etc., etc. Now, the first part is identification. So you have to provide the specific number, this small n. Are you all able to see the small n written here?
Yes, ma'am.
Yeah. Okay. So the small n actually stands for the number of studies. Okay. So the sample studies. Okay. So from each of the databases, how many sample have you collected? It's like collecting samples. It's basically the number of studies which you have downloaded from each of the databases. Okay. Then from each of these, suppose you have downloaded like 1,000 different research from these databases and registers. Now, definitely you will be removing some of those from all these 1,000 research which you have downloaded. So on the right hand side, you have to give justifications. Okay, so you see it's written records removed before screening. So before even you are screening means where you are going beyond the abstract part and you are trying to look into the details of it. Okay, so right at the beginning, before even screening, you are removing some of these. So the justifications you have to give: duplicate records removed. So how many duplicate studies did you download? So you have to mention that n is equal to how many. Then records marked as ineligible by automation tools. Okay, something which is ineligible, maybe in some other particular language it is written, you don't have any understanding about it. Okay, records removed for other reasons. You have to give the numbers and then you have to mention what are those other reasons, why have you removed those. Okay, then comes the next part, which is the screening part. So in the screening part, first you start with records screened. How many records, how many articles have you screened? And in this particular step, you have to mention how many records have you excluded. Okay, why? That also you need to mention. Okay, if not here in the write-up which you are preparing, I'll show you an example here. Then in the next part, reports sought for retrieval. Okay, reports not retrieved. How many reports you did not retrieve? Means you are excluding. Okay, reports assessed for eligibility. How many studies did you assess for eligibility? That also you need to mention. Eligibility means as per your eligibility criteria, how many of those articles have you assessed? Okay, and then the reports number of articles which you excluded. Reason 1, reason 2, reason 3. What are those reasons you have to mention, and the number of studies which are coming under each reason. Finally, how many studies you are including in the review, and reports of included studies, how many. Okay, so all these steps you need to mention as per the Prisma model. Okay, so this is a complete depiction of what are the things which you need to do. So you first form the research question following Pico and Spider, okay, and or Spider. Then the preliminary search. So you can see the preliminary search includes validate idea is not done before any journal or protocol, proposed number of included studies. Okay, so you have to propose the number of included studies in this part. Preliminary search, how many research articles are retrieved because of the preliminary search. Then you summarize the study idea and its importance to get members' attention for its global benefit on health, patients, whatever. Okay, then you mention the inclusion and exclusion criteria. What are your inclusion and exclusion criteria? Okay, then the search strategy you have to mention. Then searching databases, you see here you have to mention from PubMed, how many studies did you download from PubMed? Hmm? Then Embase, Scopus, Google Scholar, like that. Okay, all these are different databases which are there.
Ma'am, once again, ma'am.
Yes, yes.
In the first one, research question, no, Pico and spider model.
Hmm.
Only should we depend on these two things, or else it could be other than these two.
It could be other than these two as well. Not a problem. Just these are two, general tools which are generally followed. That's it.
Right, ma'am.
Okay.
Yeah.
All right. Excuse me. All right. So you see here it is written, how you can do this searching, this entire searching part. So once you have gone through the different databases, then you have to do the protocol writing. As I mentioned, approval from the supervisor, then register it, at Prospero. Okay. Then you go for title and abstract screening. Okay. So here you start, including a lot of people in your team. Otherwise, it becomes difficult. Report number selected for full text reading. So it is, definitely if you are getting like 1000 searches from all these different databases, you are not going to include all these 1000 articles for full text reading. It's not possible. So you have to mention the exact number of articles which you have considered for full text reading. Okay. Then you go for the full text downloading and screening. Okay. Then you go for manual search in the sense references from the included studies or reviews which you have already downloaded. You contact the authors and experts. You try to find out the related studies in PubMed and Google Scholar, articles that cite included report on Google Scholar as well. So this manual search is basically, it ensures that you have done an exhaustive searching of literature uh, on a particular topic. Then you go for data extraction and quality assessment. I'll come to this step next. Then data checking task, then statistical analysis, and double data checking and manuscript writing, revision and submission. So these are the steps that we will be discussing next. Okay. This is another example. So this is actually a Prisma model, which I had reported in one of my published paper. It's a systematic review which was done. Okay, and it got published in Frontiers in Global Women's Health. So you can see the Prisma model that I had mentioned here. So database search, each of the databases I had mentioned, all of which I search for the research, and then the number of articles which related articles which I got from each of these search engines, and the number of articles which were retained. Okay. Then I mentioned that after duplication, systematic reviews and qualitative research were excluded, then 101 studies were retained. Okay. Then I mentioned that each of these three steps actually tells about how many, it's like funneling down the screening at each stage, and why I rejected a number of studies. So for example, here I started with 57 studies because these actually focus on the impact of COVID-19 pandemic on mental health of SGM group. Then studies rejected, which included interventions, policy related issues, subjective experiences, general comparisons, because these are not providing strong scientific evidence. So these were removed. Okay. Then in the next step, studies written after further screening, full text assessments, n is equal to 23. 23 studies were screened for full text assessment. Here again, some of the studies focusing on methodology issues, reviews, qualitative research were rejected. Okay. Then finally, studies written after checking for inclusion criteria was n is equal to 16. Studies not matching inclusion criteria were rejected. How many studies? 7. Okay. So finally the entire systematic review was conducted following this, considering the 16 studies which were conducted around the world. So you see, it all started with 208 searches. Then you go down doing screening at each stage, and finally selected 16 studies out of this 208 searches for the final systematic review done. Okay, so that's the PRISMA model that you have to report whenever you are doing any systematic review and or meta-analysis. Okay. Another example I've given here. Okay. Now coming to the inclusion and exclusion criteria. So these are also very important when you are mentioning how you are selecting studies for your meta-analysis. You have to very clearly mention the inclusion and exclusion criteria at each stage. Okay, for selecting your studies. The exclusion criteria mostly are unrelated, duplicated, unavailable full text or abstract only papers. Sometimes you will find that some abstracts are available, but the full text is not available because probably the journal comes in a print version only. Okay, so those are your exclusion criteria. These should be stated in advance to refrain the researcher from bias. You cannot just go on doing the screening and then conveniently mention your exclusion and exclusion criteria and start doing the review. You can't do that. Okay, right at the beginning of your method section, you have to mention the inclusion and exclusion criteria very clearly, and then start with the review process itself. The inclusion criteria would be articles with the target patients, investigated interventions, comparisons between two studied interventions, whatever you are considering for your systematic review or meta-analysis. Briefly, it would be articles which contain information answering our research question. But the most important is that it should be clear and sufficient information, including positive or negative, to answer the question. Okay. So this is an example I've given here. So you can see it's again from my own study, published one. So 16 studies were selected following the inclusion criteria. So what are the inclusion criteria? Study subjects belonging to sexual and gender minority groups, number one. Subjects are adults. Subjects experiencing symptoms of depression and anxiety. Study reported quantitative assessment using questionnaires instead of semi-structured interviews. Okay. Sample characteristics clearly mentioned in the paper. Study objectives focusing on the impact of COVID-19 on the psychological health of SGM group. Details of testing materials discussed clearly. Statistical analysis reported and discussed elaborately. And results indicate a significant impact of the pandemic on the psychological health of SGM group. So these were the inclusion criteria which were mentioned in the method section, and all the studies, all the 16 studies which were selected finally for the systematic review, addressed all these specific inclusion criteria. All the other studies which were not including any of these, missing out on any of these, were excluded. Okay, so this is something which you have to mention very clearly right at the beginning. Okay,
Ma'am, this is only for the review of literature, ma'am. Inclusion, exclusion that you have mentioned.
No, for both systematic review and meta-analysis, because meta-analysis is actually based on the systematic review. You cannot do meta-analysis without doing a systematic review.
Okay, ma'am. Yes, ma'am.
Okay. Next, data extraction and quality assessment. So this step entitles the data collection from included full text in a structured extraction Excel sheet. Generally, what happens is that the researcher prepares an Excel sheet with the studies and the type of information which you are getting from each of the studies. It becomes very convenient in that way. And the process of extraction should be executed by 2-3 independent reviewers. Okay, so each of them review each of the studies and then extract the data from this entire set of studies which you are considering. So data presented in graphs would be extracted. There are many software tools available these days, like the web plot digitizer. A variety tools are also available for the the quantitative assessments depending on the designs, like the ROP2 Cochrane tool for randomized controlled trials, RCTs. Okay, NIH tool for observational and cross-sectional studies, Robbins one tool for non-randomized trials, Quadus 2 tool for diagnostic studies, QIPS tool for prognostic studies, CARE tool for case reports, Toxer tool for in vivo and in vitro studies. So all these are different types of tools which are available, generally used in epidemiological research. All these types of researches you will find in epidemiological research and clinical medical research. So there you have a number of tools available. But you can also do a quality assessment of the studies which you have considered using a very simple JBI critical appraisal checklist. Okay, so this checklist was actually provided by the Joanna Briggs Institute in 2014, and it includes 10 different criteria. Okay, so you can see it's like each of these are like, was the sample representative of the target population? Yes, no, unclear, not applicable. Were study participants recruited in an appropriate way? Was the sample size adequate? Were the study subjects and the setting described in detail? So what happens is that the 2-3 different reviewers, they assess each of the study considered, okay, separately for this 10 criteria, and give a rating based on these criteria. Okay, then the all the data coming from these 2-3 different researchers, it's combined, and the researchers then evaluate whether each of the study which have been considered finally for the review to be done, whether all these are meeting the quality requirement of the review or meta-analysis or not. Okay, so for example, in my systematic review, I had done the quality assessment using this JBI checklist. Okay, so you can easily do it in this way. Next, data checking. Okay, this comes in when you are considering the meta-analysis part. Okay, now we are gradually going into the meta-analysis part, which is definitely an extension of the systematic review. In systematic review, we go through the article and then we look into the different types of aspects or the issues which we consider, but then we present it in a tabular form, and that's it in systematic review. But when you are trying to do a meta-analysis, it goes further beyond it. Okay, so in this step, what happens is that due to the expected human error and bias, a data checking step is recommended, in which every included article is compared with its counterpart in an extraction sheet by evidence photos to detect mistakes in data. Okay, so these days you will be seeing that the different journals, they ask you to submit your data as well. Okay, so the one chief purpose for doing this is that whenever some researcher is considering your study for doing a systematic review, the researcher can simply mail to the journal, or look into the supplementary articles provided along with the article to find the data. Okay, because for doing the meta-analysis, you need to have access to this data set of individual studies which you are considering. Okay, so once you get the data, okay, you have to check it for any type of mistake that can be there in the data. So these articles can be assigned to 2-3 different independent reviewers, ideally not the ones who perform the extraction of those articles. So if you have a large team of researchers, then it's fine. Otherwise, you will have to rely on the 2-3 reviewers who are there with you. So when resources are limited, each reviewer is assigned a different article than the one he extracted in the previous stage. Okay. Once the data checking is done, then you start with the statistical analysis in meta-analysis. Okay. So Okay. Now comes the tricky part. So here, investigators actually use different methods for combining and summarizing findings of included studies. So before analysis, there is an important step called cleaning of data in the extraction sheet. So what happens is that when you get, say for example, you are including 20 different studies. So you get the data of all these 20 different studies, okay? And then you get the data in one single sheet, which is the extraction sheet, okay? Then you need to clean the data here, which is a very important step, where the analyst organizes extraction sheet data in a form that can be read by analytical software. So generally what happens is that in meta-analysis, since a lot of statistical techniques are involved, you need to use some particular statistical tool for carrying out the analysis, right? So for example, if a researcher is using R software, okay, then the data has to be coded in a particular way so that it suits the requirement of the R software. Okay, so data in this data cleaning step, the data is organized in that way, which makes it suitable for a particular software which you are going to use. Okay, so the analysis consists of two types, namely the qualitative and quantitative analysis. Qualitative analysis is generally done in the systematic review studies, while the quantitative analysis consists of two main types, the meta-analysis and the network meta-analysis. Okay, I will discuss the network meta-analysis as well. So here in meta-analysis, where you are you are doing the quantitative analysis of the data, there are many different types of analysis are done, like the subgroup analysis, sensitivity analysis, cumulative analysis, meta regression, which are done as appropriate for testing whether the results are consistent or not, and investigating the effect of certain confounders on the outcome and finding the best predictors. Publication bias should be assessed to investigate the presence of missing studies which can affect the summary. I will discuss what is publication bias. Okay. So meta-analysis is typically a two-stage process. In the first stage, a summary statistic is calculated for each study to describe the observed intervention effect in the same way for every study. For example, summary statistic may be a risk ratio if the data are dichotomous, or a difference between means if the data are continuous. It can be any statistic, means representational score, which will tell you whether there is a significant difference between the intervention or the effect size, whatever you are trying to find out. Okay. In the second stage, a summary or combined intervention effect estimate is calculated as a weighted average of the intervention effects estimated in the individual studies. So this weighted average is defined as the sum of estimate multiplied by the weight by the sum of weights. Okay. Note that if all the weights are same, then the weighted average is equal to the mean intervention effect. Bigger the weight given to the ith study, the more it will contribute to the weighted average, which means that in meta-analysis, mostly what we try to find out is that suppose some intervention is being given, what is the mean intervention effect that you are getting in this case? Okay, so this mean intervention effect is something that we are interested into, and what is the effect size of this mean intervention? Okay, so in the second stage, we look into this part. So you get a summary statistic for which describes the entire observed intervention effect for all the studies, and then in the second stage you get an effect size of this intervention. Okay. The combination of intervention effect estimates across studies may optionally incorporate an assumption that the studies are not all estimating the same intervention effect, but estimate intervention effects that follow a distribution across studies. This is the basis of a random effects meta-analysis. Okay. Alternatively, if it is assumed that each study is estimating exactly the same quantity, Then a fixed effect meta-analysis is performed. I will discuss each of these in detail. Standard error of the summary intervention effect can be used to derive a confidence interval, which communicates the precision or uncertainty of the summary statistic. If you can remember right at the beginning, I mentioned that meta-analysis is actually the potential advantage of meta-analysis is that it helps us estimate the precision of any summary estimate. So when I'm saying that okay, this the effect size of an intervention is this, then whether it is um, you know um, falling within the confidence interval or not. Okay, so it basically it tells us how precisely we are able to estimate this summary statistic. Okay. Also to derive a p-value which communicates the strength of the evidence against the null hypothesis of no intervention effect, as well as yielding a summary quantification of the intervention effect. All methods of meta-analysis can incorporate an assessment of whether the variation among the results of the separate studies is compatible with random variation, or whether it is large enough to indicate inconsistency of intervention effects across studies. Problem of missing data is one of the numerous practical considerations that must be thought through when undertaking a meta-analysis. In particular, review authors should consider the implications of missing outcome data from individual participants. Okay, so we will come to this. How missing data affects the meta-analysis part. So we will start with each of the different types of meta-analysis that are generally conducted. We start with the aggregated meta-analysis. So it's a statistical method, ADMA. It's a statistical method that combines the summary statistics of several studies to estimate an outcome. For example, a researcher might be looking into the gender differences observed with respect to, say, for example, intelligence. Okay. Now there can be like hundreds of studies which have been conducted all across the around the world on whether there is a gender difference with respect to intelligence, right? Now the researcher might be interested to estimate one single outcome which will tell that what is the suppose there is a significant difference, so what is the size of this difference. Okay. So that this one single estimate, one single outcome that the researcher wants to find out from all these hundreds of the studies, 100 studies taken together, actually requires the aggregated meta-analysis to be done, because this combines the summary statistics of all the individual studies, 100 different studies, to estimate one single outcome. Okay, so it uses a statistical analysis to generate a summary estimate using effect estimates of individual studies reported in the published literature. ADMA combines the grouped data of primary studies. For example, it involves extracting data on effects or associations and their variability. It is different from individual patient data meta-analysis, IPDMA, which synthesizes the individual data of primary studies. Okay, this is specific to patient data only. ADMA is the most commonly used of the three quantitative approaches because it can be completed relatively quickly. It's low cost. Data it uses is relatively easy to access as well. So it is more useful than the IPDMA. Okay. The IPDMA, on the other hand, is also known as a retrospective pooled analysis, okay, which uses statistical analysis to generate a summary estimate using individual participant data from published and unpublished studies. So as you can see, it requires each of the individual participant data from all published and unpublished studies on a particular topic. Now you can understand that how challenging it can be. Okay, so of course it takes more time to complete, costs significantly more, of course, to cover cost of personnel, data housing, data cleaning, harmonization, all these are required. And it can also face challenges in obtaining the data because one researcher may not agree to share the original data with the researcher. Okay, so that's why it can be very difficult to obtain each of the individual participant data, not one single summary statistic. Okay, so that's why it is a difficult one than the APDMA. Okay, despite these challenges, researchers are rewarded with increased control over the data and analysis, which allows them to reduce some of the between study heterogeneity that results from exclusion criteria, covariate selection, and analysis selection. That's why it's sometimes used. Further, the use of individual data allows researchers to pose new questions that may not have been the goal of the original studies and increases the statistical power to investigate rare diseases and exposures. So it is possible that if you are doing a meta-analysis on a particular uh, phenomena which is very rare, okay, say for example, a very rare type of disease, okay, and maybe you have just a handful of studies published in that particular field, maybe 5 to 10 different studies, then probably it is possible to obtain and get access to the individual participant data from all these studies which have already been conducted, and then you can carry out the IPDMA in this case. Okay, but it's of course it is time consuming and very very costly. Okay, the third one is the cumulative meta analysis, which is a statistical procedure that calculates summary estimates from the results of similar trials. It's a process of updating the results of an existing meta-analysis to incorporate new study results. So basically uh, considers all other meta-analysis which have already been done, and then you do another cumulative meta-analysis to integrate the results in a better way. Okay, so to get some new study results as well. So it's a sequence of meta-analysis performed on subsets of the studies, starting with a single study and adding the other studies one at a time. It shows how the overall estimate changes as each study is added to the pool. So it's one of the most popular ways to present time varying evidence, something which varies over time. If you are looking into something like that, then you can be doing a cumulative meta-analysis and it will be useful. So it has been proposed as a tool to evaluate evidence aggregation, mostly used in medical research. For example, it has been applied to RCTs of streptokinase treatment of acute myocardial infarction. Okay, so a very specific type of problem on which RCTs have been conducted already. So cumulative meta-analysis can be applied to that particular problem because it is something which is a time varying issue or a problem with a time varying evidence. So you can apply the CMA on that type of specific topics. Okay, network meta-analysis. This is a statistical technique that compares multiple treatments for a medical condition at once. NMA combines direct and indirect evidence within a network of randomized control trials. Again, it is more applicable into medical research. It can be used to integrate the results of multiple studies in which multiple treatments are compared, often in a pairwise manner. Before conducting an NMA, three major assumptions should be checked: similarity, transitivity, and consistency. What is similarity? This assumption applies to direct comparison. It refers to the equivalence of trials within each pairwise comparisons in the network. Transitivity applies to indirect comparisons, concerns the validity of making indirect comparisons. And consistency applies to mixed comparisons where you have both direct and indirect effects. Refers to the equivalence of direct and indirect evidence. Generally, what we do here is that we get a network diagram, which is a graphical depiction of the structure of a network of intervention. It consists of nodes representing the interventions in the network and lines showing the available direct comparisons between pairs of interventions. So you can see here, this is actually a network model. And say, for example, you have this 4 different interventions, A, B, C, D. So you can see here, between A and D, there are 2-arm studies which are comparing A to D. Okay, so you have a pairwise comparison between 2 different treatment interventions. Okay, done. Then you can consider 2-arm studies comparing A to B. So A and B, again, a pairwise comparison being done between 2 different interventions, A and B. So these are direct comparisons which you are doing. You can have a 3-arm studies comparing A, B, and D. Okay. Then you can have 2-arm studies comparing C to D. Again, a direct one. 2-arm studies comparing B to C. Okay. So you see, when you have a study, you have studies where, RCTs where you have like pairwise comparisons which were done, you can integrate all those studies together into this network model and do a meta-analysis of all these at once. That's the advantage of a network meta-analysis. Okay. Meta-analysis of diagnostic test accuracy. Okay. So we have different in medical research again, and clinical research as well. You will find that several researchers possibly testing the accuracy of a particular intervention or a test in a clinical population. So if a researcher wants to do a meta-analysis of all those diagnostic test accuracy of a particular testing material, then this type of a meta-analysis can be done. And this is represented by a summary statistics and a summary line of a basic 2x2 table consisting of true positive, false negative, and true negative values. True positive is when there is there is actually a diagnosis and the testing material has also shown that there is a positive diagnosis, then it's a true positive. False positive is when there is an absence or a lack of a problem, but the testing material is saying that there is a problem, making a diagnosis, then it's a false positive. False negative is when there is no problem. Sorry, there is a problem, there is a clinical problem there, but the testing material is not being able to give a diagnosis, then it's a false negative. And true negative is when there is actually a problem, a clinical problem is there, and there is no problem and the diagnostic tool has also given no diagnosis, then it's a true negative value. So all these can be combined in a summary line. And in general, the representative summary statistics include sensitivity, specificity, positive predictive value, negative predictive value as measures of the meta-analysis of DTA. Okay, so you can see what you are seeing here is a SROC curve. Okay, so this type of curve is actually conducted by plotting the sensitivity on the y-axis and the false positive rate on the x-axis. Okay, so a linear regression is performed here to calculate the slope and the y-intercept. So you can see here all these different studies and the location of these studies in this particular plot. So the false positive rate should be ideally low and the sensitivity should be high. That's how it should be. Okay, so this SROC curve actually tells us about, it summarizes the estimates of each of these studies. Okay, so it plots the sensitivity and the false positivity of each study, mathematically manipulates the true and false positivities, then perform a linear regression to calculate the slope and y-intercept, It is actually recommended for evaluating the accuracy of a diagnostic test. A receiver operating characteristic ROC curve graphs the sensitivity and true positive rate against 1 minus specificity or the false positive rate. Each point on the graph is derived from a different threshold. Okay. So this is again a very um, you know uh, what should I say, a very um, uh, a rigid way of finding out whether the diagnostic test is performing well or not, depending on how it has been reported across all the different studies which have been considered for the meta-analysis. Okay, so for calculation of the summary statistics of DTA studies, an appropriate model needs to be selected. Okay, so these models can be a bivariate model or a hierarchical model. Um, in the bivariate model, a binomial distribution that directly models the sensitivity and specificity is assumed for within study variations, and a bivariate normal distribution is assumed for between study variations. The hierarchical model assumes a binomial distribution for within study variations. For between study variations, a hierarchical distribution is assumed for the parameters included in the logistic model by applying the logistic regression model to determine the probability of a binomial distribution. So I'm not going into the details of all these. If you are, just to give you an idea of how it is done, this meta-analysis of the diagnostic test accuracy is done. I just mentioned the SROC curve, and if you are interested to do something like this, you can go into the details of it to find out, how each of these models are applicable for, between study variations or within study variations. Okay. All right. So I hope this is clear. Till here, it is clear to all of you. Is it making sense?
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay. Okay. So now I'll be discussing the Cohen's d. Cohen's d is actually a very popular measure of that we use in meta-analysis. So it's a standardized effect size. Okay, that measures the difference between two group means. Effect size are the most important outcome of empirical studies. When you are comparing two different group means across several studies, you need to understand what is the effect size. You might be getting a significant difference between two different groups. All right, but whether this difference that you are observing, whether it is large enough or not, okay, that is something that you need to find out. So effect sizes can be used to determine the sample size for follow-up studies, or examining effects across studies. All these, for all this you can be using the effect size, like the Cohen's d. So this one expresses the difference between two means in standard deviation units. It tells you how many standard deviations are between the two means. So Cohen suggested that a d of 0.2 represents a small effect, 0.5 a medium effect, and zero 0.8 or higher a large effect. A positive d indicates that the first mean is higher, while a negative d indicates that the second mean is higher. All right, that's the interpretation of Cohen's d. But effect sizes can have different names, although they are basically the same entity. It can be referred to as r square or eta square, and or they have received the same name despite being calculated in different ways. So the D family, which consists of standardized mean difference, that's the most general and the usual one that we use here, and the R family, which measures the strength of association. So conceptually, the D family effect sizes are based on the difference between observations divided by the standard deviation of these observations. So, um, as it is mentioned earlier, that it is given in standard deviation units. Okay, so it's a standardized measure that you are getting here. The R family effect sizes describe the proportion of variance that is explained by the group membership. So you have two different groups. So for example, a correlation of 0.5 indicates 25% of the variance is explained by the difference between the two groups. Okay, so these effect sizes are calculated from the sum of squares for the effect divided by the sum of squares for other factors in the design. So that's a very common measure that we use in meta-analysis, the effect, Cohen's d. Okay, next comes the odd ratio, meta-analysis of odds ratio. What's this odds ratio? It's a measure of the association between two categorical variables. So meta-analysis use statistical techniques to estimate an overall effect from the effect sizes of individual studies. Okay. Here, a very popular method is the Mental-Hensel method, which provides a pooled odds ratio across the strata of fourfold tables. Meta-analysis is used to investigate the combination or interaction of a group of independent studies. Okay, so here the basic requirement is that this phenomena that you are considering should be categorical in nature. So, for example, the odds of an event happening is the likelihood that an event will occur, expressed as a proportion of the likelihood that the event will not occur. For example, if A is the probability of subjects affected and B is the probability of subjects not affected, then odds is equal to A by B. So in meta-analysis of odds ratio and risk ratio is also something similar to this. So an intervention which is or maybe you have two different groups, the clinical and the non-clinical, or two different clinical groups, one receiving the treatment and the other not receiving the treatment, whether one is having shorter duration for survival than the other group or not. Okay, so you have two categories in odds ratio and risk ratios type of studies. You need to have two categorical aspects, and then you are in such kind of a meta-analysis, the standard practice is to exclude studies from the meta-analysis where there are no events in both arms. Okay, so you have to have events occurring in both the categories. Okay. You can have the hazard ratio as well, which is similar to the risk ratio. So this is a measure of the relative hazard in two groups. Here, you can be using the Cox-Mantel estimate, which is calculated by dividing the hazard rate under treatment by the hazard rate under control. So it measures the change in risk of treatment versus control over the follow-up period. So one group is receiving the treatment and the control group is not receiving the treatment. So what is the change in risk that is happening over time? So if you have studies like those and you want to do a meta-analysis of those type of studies, you can go for a meta-analysis of hazard ratio. So a hazard ratio of 1 represents no difference between the groups. If the hazard ratio is greater than 1, then it indicates that the treatment group has a shorter survival than the control group. If the hazard ratio is less than 1, then it indicates that the group of interest is less likely to have a shorter time to the event than the reference group. So, for example, a researcher wants to find out that after giving a particular type of treatment, maybe there are two groups. Okay, the participants having a particular type of cancer. Okay, so a specific type of treatment is being given. What is the probability that the group which is receiving the treatment, they will develop further symptoms, or whether they have a shorter survival than the control group who are not receiving the treatment, or the other way around. Okay, so that can be a suitable problem where the researcher might be looking into meta-analysis of hazard ratio. So in systematic reviews and meta-analysis, time to event outcomes are the most appropriately analyzed using HRs, okay, hazard ratios. Meta-analytic results are considered the most trustworthy source of evidence by the evidence-based medicine literature. So, fields where evidence-based researchers are considered as the trustworthy source of evidence, like epidemiology, then public health. In certain types of fields, the meta-analysis of hazard ratio is a very common type of tool that is used. Okay. Forest plots. All right. So forest plots are actually very popular when you are considering a number of lot of different papers for your meta-analysis. So trying to look into so many different papers can be hazardous, and it can be very difficult to answer the research question which you have framed. So this becomes especially true if the papers analyzed come to different conclusions and have different statistics either in favor or against an association. That's a very common thing that you will get in meta-analysis, any kind of meta-analysis that you will be doing. So what a forest plot does is that it takes into account all the relevant studies asking the same question, identifies a common statistic in said papers and displays them on a single set of axes. Okay, so doing this allows one to compare directly what the studies show and the quality of that result all in one place. So this is an example of the forest plot. Generally, if you are doing a meta-analysis, it is expected that you will be reporting a forest plot of all the studies which you have considered. So I guess this is visible to all of you. The um, writings are visible.
Yes, visible.
Okay. So here you can see you have individual studies on the left hand side, the first column that you can see. So you have, like, for example, there are 6 studies. So these are individual studies, and the rows actually tells you about the each of the study that you are considering. Okay, so these are the different, suppose you are considering some intervention studies. So um, the number of events that has occurred in the intervention group and the number of events which has occurred for the control group, and in a particular study, and then the weightage that you are getting, then the risk ratio, okay, and the 95% confidence interval for the risk ratio. Okay, so what you get here is that, as you can see, this is the forest plot here on the extreme right. Whatever you can see, that's the forest plot. So this uh, you know line, which this vertical line which you are seeing in the center, this is the line of no effect. That signifies no difference between groups if the confidence interval crosses the line. The confidence interval is actually this these horizontal lines which you can see for each of the studies. Okay, so this entire line is actually representing the width of the confidence interval for this particular study. For example, for study 5, the confidence interval is 0.01 to 7.95. So that's the width of this horizontal line that you can see. Okay, and the box which you can see at the middle, that's the point estimate. Okay, that estimates the true effect in the population in this particular study. So the effect that you are getting for each of these studies, that is represented using this square box at the middle. Okay, so of course, if it is a large one, then you will, of course, you will find that the box will be a larger one. Okay, the effect estimate that you are getting here. And this diamond shaped, black diamond shaped shape that you are seeing here, this one shows the overall effect size, okay, from all the studies pulled together in the meta-analysis. Okay, and in this the x-axis which you are seeing here, this actually shows this entire range, within which you can see that on the right hand side, if the estimate comes on the right hand side, then it favors the control. If it goes to the left hand side, then it favors the experimental group. Okay, here you can see that the heterogeneity, that here you are able to see that there is a I-square. We will be discussing what is this I-square. It is something that we use in heterogeneity, in finding out whether there is heterogeneity among all the studies or not. Okay, and the p-value for the overall test effect, that demonstrates the overall statistical significance between all the studies included in the meta-analysis. Okay, so that's about the forest plot. And So that's a description of whatever I just mentioned there. Um, the I-squared statistics, I'll just mention this. So I-squared statistic actually gives us an idea about the heterogeneity of the studies, that is how consistent they are. If the I-squared value is more than 50%, then it might mean that the studies are inconsistent due to a reason other than chance. This might make the conclusions you draw from the forest plot questionable. So you can see here the I-square is 0%, which means that the studies are consistent. So you can consider all these studies safely for your meta-analysis. Okay. This is another example of the forest plot. These are the hazard ratios, expressed in each of the studies, and how it is plotted. And so you can get a direct comparison between all these different studies. Okay, the hazard ratios and the confidence intervals. You can directly compare for each of these studies taken together. Okay. Another example you are seeing here. Okay, here the odds ratio are plotted. It depends upon the type of problem which you have considered. Okay. Another example. All right. So heterogeneity tests, there are certain tests that we need to do to find out whether there is a heterogeneity among all the studies which you have considered or not. And it can be, this heterogeneity can come from study designs or sample characteristics. So you can be using a Cochrane's Q statistic and also the inconsistency index, that's the I-square. Okay, so Cochrane's Q statistic is a weighted sum of the squared deviations. It's like a chi-square, of not a chi, but a x. The symbol is almost similar. Um it has a poor power to detect heterogeneity among a small number of studies. So if you have very small number of studies, it's better to go for an inconsistency index, because it is less influenced by the number of studies which you are comparing. So this is basically a percentage of total variation across studies that is due to heterogeneity. So that is what we observed there, percentage of total variation. So closer it is to zero, the better consistency you have across all the studies. If it's more than 50%, then it means that all the studies which you have considered are not very consistent among each other, and there are a lot of heterogeneity among them arising from sample characteristics or study design, and that actually challenges the meta-analysis which you are doing. Okay. Fixed effect models, whenever we are doing a meta-analysis, you can have a fixed effect approach or a random effect approach. Fixed effect approach assumes that all the studies included in the meta-analysis are estimating the same underlying true effect. Okay, that's the basic assumption. So variability is assumed to originate from within each study, not between the studies. That's the basic assumption you have for fixed effect models. So under a fixed effect approach, the inverse variance method for weighting studies is used, and studies are weighted by the inverse of the study specific variance, and the summary estimate is calculated as a weighted mean of the individual estimates. So because the studies are only weighted by the variance between individuals within a study, smaller studies which are generally expected to be less precise will be weighted less, and larger studies will be weighted more. That's one of the hazard of going for the fixed effect models. Okay, but if you are considering the random effect models, the basic assumption becomes that there is no true effect estimate, but rather a normal distribution of effects. So variability can be arising from both from within and between study variance. So here, when calculating the pooled estimates, individual study estimates are weighted by taking into account both within and between variance. A random effects approach to deriving the summary estimate means the weights are more balanced. Okay, so that small studies are not trivialized as much and large studies are not weighted as heavily. The trade-off for this approach is precision in the summary confidence intervals. Generally, summary estimates using random effects models yield larger pooled variances and confidence intervals than the fixed effect approach. So when you have a very large confidence interval, of course, the precision will go down. Okay, so that's the trade-off if you are using a random effects model. All right, coming to publication bias assessment. This is again another very important step in meta-analysis, uh, especially if you are doing a meta-analysis of aggregated data. This one should be assessed definitely. So publication bias occurs when a greater percentage of studies suggesting beneficial or larger effects are published, but fewer studies reporting null effects, negative effects, or smaller studies are published. Okay, so many a times it happens that for example, if you are trying to look into suppose a researcher is trying to find out the effect of COVID-19 pandemic on say mental health issues. Okay, so there is a very high probability that you will be getting lots of studies which will be reporting that there is a very significant effect. Okay, so a lot of people experience depression and anxiety and other forms of problems during this period. But you will find very small number of studies or even unpublished ones which will be telling you otherwise. Okay, so if you are actually working with that kind of a problem, okay, you are looking into that type of a problem, and that is the case, then it actually leads to publication bias because you are not getting enough amount of enough number of studies on the other arm. Okay, so if there is a publication bias, then the meta-analysis of aggregated data will report a summary effect that only reflects effects found in published studies and will not reflect the true effect or distribution of true effects in a population. So this true effect is actually dependent on both the sides, whether there is a positive impact or there is a negative impact. Both if you can consider, then only you can get the true effect. But if you have only the positive effect published, not the negative ones, then how will you know, right? So there can be other types of biases that can arise from the citation bias. So what is this citation bias? Even when published, sometimes it happens that studies with negative or inconclusive findings are less likely to be cited by related literature. This makes it harder to detect them through reference searches. So of course, if it is less cited, then you won't be able to find it, right? It will be difficult to find such type of studies. Then it can lead to citation bias. Time lag bias. Studies with positive results are often published earlier than those with unfavorable findings. This means that findings of recently conducted studies with positive findings are often already available, while those with non-significant results are not. Maybe coming at a later stage. So that leads to time lag bias. Multiple publication bias. Results of successful studies are more likely to be reported in several journal articles, which makes it easier to find at least one of them. The practice of reporting study findings across several articles is also known as salami slicing. Okay, that's a specific term that we use, salami slicing. Okay, so then you have language bias. In most disciplines, primary language in which evidence is published is the English. Publication in other languages are less likely to be detected, especially if the researchers themselves cannot understand the contents without translation. If studies in English systematically differ from the ones published in other languages, then this can also introduce the language bias. And finally, the outcome reporting bias. So many studies and clinical trials in particular measure more than one outcome of interest. Some researchers exploit this and only report those outcomes for which positive results were attained, while the ones that did not confirm the hypothesis are dropped. This can also lead to bias. Technically speaking, the study has been published, but its unfavorable result will still be missing in our meta-analysis because it is not reported. So this is a very strong bias that you will find in meta-analysis research. it has been seen that if a positive outcome has been reported, that has been included in the meta-analysis. But if there is a negative outcome which has been reported, it is excluded. Okay, so that can be the outcome reporting bias. So generally what happens is that we use a funnel plot for actually find out or to understand this publication bias. How do we do it? So this funnel plot is actually a visual tool that can help investigate publication bias and other biases in meta-analysis. It's a scatter plot that plots the treatment effects estimated from individual studies against a measure of study size. I'll show you the plot first. Yeah. Is it visible to all of you?
Yes, visible.
Okay. So you see, it got its name because of this shape, this shape like a funnel. Okay. So how can we interpret this funnel plot? So each included study is represented as a dot. You can see many dots you can see here. So all these dots are actually the individual studies which have been included in the meta-analysis. The y-axis represents a measure of study precision with standard error being commonly used. Larger studies with greater precision are displayed at the top and studies with lower precision at the bottom. Other measures such as the reciprocal of standard error, reciprocal of sample size, variance of the estimated effect can also be used in the y-axis. So this y-axis, you can see standard error is used. So those dots which you can see here at the upper level actually shows that these are having higher precision, and those which are towards the bottom, they are having lower precision. Okay, that's how we interpret it. Okay. X-axis displays the study estimated effect size for an outcome. The scale for the x-axis can include risk ratios or odds ratios, depending upon whatever you are analyzing, or continuous measures such as mean difference or standardized mean difference. Okay, so there's the x-axis. Here you can see the odds ratio is plotted. In the absence of both bias and heterogeneity, 95% of studies would be expected to lie within the diagonal dotted 95% confidence interval line. So this dotted line which you are seeing is representing the 95% confidence interval. Okay, so this is another example which you can see here. Okay, and yeah, I'll explain this again. This is another example which shows that a number of studies being plotted here. So as you can see, the studies which are towards the top, they're considered to have higher precisions, and the x-axis is considered to be having a standardized representing the standardized mean differences. So there are 3 studies which are showing that there is a very high mean difference. So the effect size is high, but the precision is questionable in that case. Okay, so this is again an contour enhanced funnel plot, which is another type of funnel plot where this contour is enhanced, and this contour is actually representing the different significance levels. Okay, so when you are getting this contour, you can see here this index. As you can see, this darker portion is showing that the p value is less than 0.1, and this lighter portion is actually showing the p less than 0.01. Okay, so when you are getting this contour, then you are able to see that which among these studies are there is a precision, but at the same time whether they are having this effect size, whether it is significant or not. The standardized mean difference means the effect size which is being represented here, whether it is significant or not. So now you can see that these studies, this particular dot, let me just consider the spotlight here. So you can see these studies, this one and this one, these are actually precise, but at the same time, the effect size is very significant, okay, highly significant, less than 0.01 p. And these four studies, the precision is not as high as this one, but these are also showing, um, significant effect size. But on the other hand, these three studies, which are actually having the effect size being high, but not significant at all. Okay, so not as significant as these. So that's how you interpret the uh, funnel plot, and it actually shows that whether there is a publication bias or not. For example, if your effect size is high but it is not significant, then there is a possibility that there can be publication bias. But funnel plots does not give you a very quantitative assessment of whether there is a strong publication bias or not. So that's why there are many other statistical tools that we use. One of those is the Eggers regression test that you can use for finding out whether there's a potential publication bias or not. So this is a linear regression of the intervention effect estimates on their standard errors weighted by the inverse variance. Okay, so what happens here is that the Eggers test actually regresses the standardized effect sizes, that the effect size you are getting for each of these uh, studies on their precision, that's the standard error. So in absence of publication bias, you are supposed to get the regression intercept as 0. Okay, the regression intercept should be 0 if there is no publication bias. If you find that the intercept is not 0, okay, if it is more than that, then it shows that there is a publication bias. Okay, so the funnel plot, we can look at it to evaluate, you know but it will just give you a very vague idea of whether there is publication bias or not. But this Eggers state actually gives you a statistical a confirmation of whether the publication bias is there or not. Okay, not going into the details of it, just to consider, I would like to mention that Eggers regression test, when it is done, we do not consider the magnitude of the intercept, rather we consider the p value for the intercept, okay, to find out whether there is publication bias or not. Subgroup analysis is also another type of method that is used in meta-analysis. If you have different groups in your data coming from different maybe different gender or geographical location, like that, so those can be potential sources of heterogeneity. So that's why subgroup analysis can be done to find out whether there is a source of heterogeneity coming from this two or more different groups or not. Okay, so since the time is short, I'm just mentioning some of the basic ideas of these issues. Sensitivity analysis, another important step in meta-analysis, where there are many decisions that we sometimes take in a systematic review or in a meta-analysis. So in such cases, you have to consider the sensitivity analysis, just to find out whether the decisions which you have considered for a particular for conducting a particular systematic review or meta-analysis, whether it is the decision is correct or not. So there can be this sensitivity analysis is actually a repeat of the primary analysis or meta-analysis, substituting alternative decisions or ranges of values for decisions that were arbitrary or unclear. For example, if the eligibility of some studies in the meta-analysis, is dubious because they do not contain full details, then sensitivity analysis may involve undertaking the meta-analysis twice. First, including all studies, and second, only including those that are definitely known to be eligible. Okay, so in this particular process, you do it twice, okay, just to find out that whether including all the studies together and including only the eligible ones, whether there is any difference between these two or not. Okay, so there can be different questions which which are pertinent in different uh, uh, issues. For example, should abstracts whose results cannot be confirmed in subsequent publications be included in the review? Or when you are defining the eligibility criteria, you have to make decisions about characteristics of participants, characteristics of the intervention, the comparator, characteristics of the outcome, study design, all these. Okay, then when you are doing the analysis, what data should be analyzed? Okay, what should be the analysis method? So all these decisions you are taking while conducting a systematic review or a meta-analysis. But to what extent these are going to generate the effective scientific evidence that you want? Okay, so for such a for these purposes, you can be doing the sensitivity analysis for your um, meta-analysis. Okay. Um, I'll just skip to this. Meta-regression is also another type of meta-analysis that uses regression analysis to combine, compare, and synthesize research findings from multiple studies. Okay, so here this is also another method that we use in meta-analysis. It's an extension of the subgroup analysis that allows the effect of continuous and categorical characteristics to be investigated. So this one uses individual study as the unit of observation to assess the relationship between the magnitude of the treatment effect and different predictors. So it is like other forms of regression which are there, but specifically applicable to meta-analysis when you are considering different subgroups within your studies which you are considering for your meta-analysis. Okay. So finally, I'm coming to summarization of the meta-analysis as a method. The common methods that we use for conducting a meta-analysis can be aggregated data meta-analysis, individual participant data meta-analysis, cumulative meta-analysis, network meta-analysis, and meta-analysis of diagnostic test accuracy. How to perform? You can frame a question, form the search strategy, search of the literature databases, select the articles, data extraction, assess article quality, test for heterogeneity, estimate the summary effect, evaluate sources of heterogeneity, assess publication bias, and present results. Those are the steps that you need to follow. Strengths can be that it improves the estimate precision, identify effects in specific groups, analyze rare outcomes. It can check heterogeneity and evaluate its sources, compare various interventions, determine if new study is needed. And limitations are that it can be missing related research. There can be huge source of publication bias, selection bias. There can be unavailability of information in certain cases. There can be heterogeneity. There can be misleading funnel plots. There can be inevitable subjectivity in interpretation of data. So all these are the limitations. So just to summarize the advantages and disadvantages, I've mentioned it here. So of course, meta-analysis have greater statistical power, as we discussed. It can be used as a confirmatory data analysis method. It has greater ability to extrapolate to general population affected, and it can be considered as an evidence-based resource. Disadvantages include difficult and time-consuming to identify appropriate studies. Not all studies provide adequate data for inclusion and analysis, so it makes it very difficult to search and select data or studies for your meta-analysis. It requires very advanced statistical techniques, which some of which we discussed today. And heterogeneity of study population is a major challenge if you are doing a meta-analysis. So I'll stop here and thank you for your patient listening. I hope it's not overwhelming to all of you and made sense, at least some of it to you. So thank you very much. If you have questions, please feel free to ask. Over to you.
Yeah, Dr. Sumana, it was
Yes.
good, but it was completely theoretical. Undoubtedly, joined but little bit late. Many things fly off over my head because
It's very, very common. Yes.
yes. And just we wanted to know the practical aspect, the possible in the next sessions. I mean,
I
some
think,
go ahead for meta-analysis, how to do that, like extraction sheet, how we can use that.
all right. So, extraction sheet, it's a very personalized type of there is
True,
no general format for extraction sheet.
true,
You
true.
can have it, as per your requirement. For example, when I did my own systematic review, I prepared an Excel sheet where I, provided included all the studies which I had included in the I had selected for the systematic review, and then put all the criteria, inclusion criteria, and did a check for each of those. So it's a very personalized one which you can develop for your research. Okay. The tricky part is this extraction. As I mentioned, that you can go to each of those search engines and get a, you will, you go to Google
Particular
Scholar
tools.
and put any keyword, you will get thousands of studies coming to you. So how
Mhm.
to do the extraction? So that's a very tricky part, and I think there is no shortcut to it. Actually, you
No,
just
very
have
good.
to
Uh-huh.
go through all those studies which are there. First, you have to start with the title and the abstracts. Okay, for the titles, then go for the abstracts. Okay, then if you find that okay, probably it suits the eligibility criteria that I have for my systematic review, then you go for the full text. Okay, so automatically a such a funneling will come into process when you will be doing this extraction. But of course, it is very time taking and a very hardworking thing, because these days we have like too many search engines, and the journals, they expect you to go through each of these search engines to extract all these research and then exclude the duplications. Okay, so
Hmm.
it's a huge job actually. So I can
That's
share my published paper with all of you, so you can go through the method section, and maybe that will help you to understand the method which I had followed for my systematic review, and probably it will give you some idea about how to go about it.
right. One thing, it was very interesting part, the tools you have mentioned over there.
Yeah.
What tools could be used by the, I mean, for medical studies purpose,
Hmm.
or qualitative or quantitative?
Hmm.
Can you I mean, to give some graph kind of that which tools would be used for which purpose? Because we will see also. So I
Hmm.
think so, when we are using the tools and
Hmm.
extraction sheet and all, everything would be very clear about that.
Yes, yes, of course. If you are
Right.
using some tool, if you have some available tool with you, then
Hmm.
the extraction sheet has to be organized in that way, so that you can just put those in your um, you know uh, just to have a parity between the requirement of the tool and the extraction sheet which you prepared.
Right.
Okay, but you can do it
Get the,
manually as well.
from where we can get the tool?
Yeah, that that I don't know, because for
Ah,
my own research I did it manually.
okay.
Certain institutes, they have some licensed versions of these tools,
Okay.
but definitely they are quite expensive.
Under,
Generally medical institutes, as I mentioned, public health researchers who work in public health
hmm,
and epidemiology, they have access to this type of tools. They have licensed versions of these different tools which they use for data extraction, specifically designed for meta-analysis,
right.
systematic reviews.
True, true. So
Yeah.
without tools could not be possible. Huh?
It is possible. It is possible. It will take time and it will be exhaustive. That's it. But
Ah,
it is definitely possible. These tools have come like only a few years back. Okay,
hmm.
but before that also people used to do meta-analysis, isn't it? So
You
it
said
is
that more
possible.
than two people, I mean, it's required, no?
At least two. At least two.
At least two. Right.
Yes, at least two.
Good, good. Okay.
Okay.
Right.
Okay, dear students, any question to Shumana madam? Professor Jagdish, we have already discussed the Boolean operator
Yes, sir. Yes, sir.
for the searching.
Right.
Okay. The data extraction
True.
for the Boolean operator you can apply.
Yes.
Shumana, you have shown one card and you have told that is the linear regression, but it appears to me that is the logistic regression. Have you checked it?
One, sir, which one?
I think SROC curve, something curve you have shown. I find that is a 0, 1 in the y-axis.
Of course, it is logistic regression, sir.
Logistic
Because
regression.
it's a AUC that you will be getting.
ROC also there, yeah.
Yes. It's not linear regression, sir. Linear regression is performed for calculating the slope and the y-intercept. That's it.
Okay. So everybody has appreciated your lecture in the chat box, I find. And thank you, Professor Jagdish, raising the question.
Thank you, sir.
This is very vital.
Undoubtedly,
and
sir.
Particularly, very few know about this meta-analysis. And Shumana did research on this particular area, the systematic literature review. Therefore, I requested Shumana. Shumana did PhD under my guidance. So I am happy.
Sir, she's the best one, and she's very thorough about this meta-analysis.
Yeah. She is very deep achieving student.
And I hope, and I think so that in statistics, Dr. Sumana, meta-analysis is very toughest part.
Yes. No doubt it is, it provides the strongest scientific evidence, more than the experimental studies as well.
True.
So that's why, it's definitely complicated.
Okay. We have one trainee here. She is also Shumana, but only the name is different.
Yeah. She is
also a very good student, Shumana.
Nice.
Thank you, sir. I expect at least I can be something like this, ma'am.
No, but whose are
please pray for me.
Whose are Dr. Datta's Roy students? They would be very good, undoubtedly.
Thank you. Thank you. Tomorrow again, we will find another student from Gitam University.
Okay. What would be the topic tomorrow, sir? I mean, the next session?
Tomorrow in the morning, I think you have received the email, right?
Okay, sir.
The advanced applied psychometrics.
Oh, yes, sir. Yes.
You have received. Okay. Please join at 10:30.
Sure, sir. Sure. 10:30. Okay, sir. It's a clinical duties. Okay, sir. I will.
Okay.
Right.
So thank you, Shumana, for giving your valuable time
Thank
for
you,
our
everyone.
students.
I enjoyed.
Thank you, sir.
Thank you. Thank you, sir, for inviting me.
And to take one photo. Okay. Okay, thank you, everybody.
Thank you.
Yes.
Wishes to all of you.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you. Good night.
Good night.